Greetings everyone, we are from Group B. Will be present our practical work 2, which is produce long section and cross section plan using automation method. This practical work 2 was conducted on 2nd December 2021 and submitted on 10 December 2021. We were asked to carry out traverse network for road detailing longitudinal sections and cross section profile. Carry out the leveling network for height transfer to control point. Carry out road detailing survey to provide information for longitudinal sections and cross section. Carry out data downloading from total station to the computer. Carry out data processing using civil design and survey software. Carry out data editing using AutoCAD software. Produce long sections and cross section drawing according to the engineering standard while completing this practical work 2, and we were monitored by our lecturer, Mr. Firdaus bin Aminuddin. With this is to ensure that the work of our group is correct and runs smoothly. Horizontal control survey. Horizontal control survey coordinate horizontal positional data. This position can be referenced by parallel or plane coordinate axes. Because they are used as framework for other surveys, these surveys must be precise and accurate. These surveys provide a network of monument or point on the ground that can be used as a control for any other surveying project, such as a boundary or construction survey. The advantage of using a horizontal control survey is that lost monument can be replaced accurately. Surveys can be coordinated more than one network stations can provide a check to the work, and a reduction in the cost of the project can be achieved. Most horizontal should and will be connected to the control network. So the vertical control survey. A vertical control survey is performed for accurately determining the orthometric height, which is elevations of permanent monuments to be used as benchmark for lower quality leveling. Spirit leveling is the usual method of carrying elevations across the country from sea level, tidal, gauge. However, global positioning system GPS can be used indirectly but with less accuracy. High measurement from the ellipside as opposed to the sea level jot can be determined very accurately with GPS and only with GPS. Trigonometric leveling with a total section is not acceptable for vertical control work. Longitudinal section. Longitudinal sections are sections which follow some predetermined line defining a part of a new construction and are usually run along the center lines of the proposed work, such as new roads, canal, railway, pipeline, and others. The aim of longitudinal section leveling is to provide data for the following. First, deciding the most suitable and economic levels and gradient in its longitudinal section. Second, locating the places of cut or fill. Third, locating the place where neither cut nor fill occurs. In the cross sections are sections set out normal to the longitudinal sections. The aim of cross sections leveling is the reproductions of inaccurate sections of the ground which is to be covered by the construction works. Cross sections provide data for the following. First, deciding the most suitable and economic levels in the traverse directions. Supplying details for locating disposition, height, and slope of embankment or cutting. The objective of this practical work 2 was to expose students with the concept of data collections and recording using the total station. To familiarize students with use of total station and data downloading to the computer. Third, to expose students with the survey software to process data. To produce plan for road detailing, longitudinal sections and cross sections profile.
Next, I will continue present about work procedures for differential field test and two-pack test. DFT is implemented at work locations when daily checks have a distance difference of more than 10 mm and when each time starting a new survey job. First, what we need to do is plan pickets A and B with not less than 60.234 meter. Third, pair the ADM in A and prism in B and measure the distance A to B. Third, plan picket in C is approximately the AB line. The distance picket A to C is 6.718 meter. the distance for picket C to B is 33.516 meter. Switch ADM in C and pair prism in A and B. Measure CA and CB distance. AB distance should be compared to the number of distance CA plus CB. If it is found that the distance exceeds 10 mm, the device test cannot be used. It should be calibration test. And this is the example for measure DFT at fieldbook test.
2 PEG test. Permanent adjustment. All instruments are subject to error of calibration and adjustment. In the case of leveling instrument, the main source of instrumental error is where the line of sight produced by the crosshairs in the telescope is not parallel to the horizontal line of collimation produced by the manufacturer of the instrument. This error is known as collimation error as it affects the line of collimation. The test that we undertake to determine the amount of error and then eliminate it from our measurement is known as the 2 PEG test. This is example of 2 PEG test, 2 PT. The 2 PEG test is used to determine if the line of sight of the telescope is exactly parallel to the bubble tube. This is one of the most important prototypes of a level and rigor to be checked periodically. Below are the steps to carry out 2 PEG tests. First, set 2 points with 40 meters. Number 2, set up the level halfway between the 2 points at point C as illustrated in figure above. Number 3, the staff reading at point A and B are taken. The bubbles need to be adjusted each time before the readings. Number 4, the level is then moved to point C and reading are taken to staff at point B and A. Number 5, the true difference in elevation between point A and B is computed from the 2 readings obtained from the first setup A1 to B1. And lastly, the elevation difference of the second setup is computed A2 to B2. If the plane of sight is truly horizontal, the elevation difference of the second set is equal to the true difference in elevation A1 to B1, A2 to B2. Set the distance of AC, CB, BD. If the difference between AC, E, so the difference of CB, BD, E, thus the distance of DA, 3E. Refer to the following table. Instrument at station C, D. Staff reading at A, A1 equal 3.75, A2 equal 7.86. For B, B1 equal 4.25. For B2 equal 6.36. The difference A equal 0.5 unit higher than B, actually different. B equal 1.5 unit higher than A, appearance different. Note, if A2 minus B2, A1 minus B1, so adjustment must be set up. with instrument at D actually reading A2 equal A plus 3E, with instrument at D actually reading A2 equal A plus 3E. Thus, reading at A equal A2 minus 3E, actual reading B2 equal B plus E. Thus, reading at B equal B2 minus E. Hence, actual correction equal actual reading at A minus actual reading at B. A2 minus 3E minus B2 minus E. 7.86 minus 3E minus 6.36 minus E equal 1.5 minus 2E, but two different equal A1 minus B1, 3.75 minus 425 equal negative 0.5. Negative 0.5 equal 105 minus 2E. 2E equal 2, E equal 1 meter distance. With instrument at D, actual reading at A. A2 equal 7.86 minus 3 equal 4.86. Actual reading at B, B2 equal 6.36 minus 1 equal 5.36.
Control survey horizontal. Horizontal control surveys coordinate horizontal positional data. This position can be referenced by parallels or plane coordinate axes because they are used as a framework for other surveys. These surveys must be precise and accurate. These surveys provide a network of monuments or points on the ground that can be used as the control for any other surveying project, such as a boundary or construction survey. The advantage of using a horizontal control survey are the lost monuments can be replaced accurately, surveys can be coordinated, more than one network station can be provide a check to the work, and a reduction in the cost of the project can be achieved. Most horizontal should and will be connected to the control network. Next is vertical. A vertical control survey is performed for accurately determining the orthometric height elevation of permanent monuments to be used as benchmark for lower quality leveling. Spirit leveling is the usual method of carrying elevation across the country from sea level, tidal gauges. However, Global Positioning System (GPS) can be used indirectly but with less accuracy. Height measurement from the ellipsoid as opposed to the sea level joint can be determined very accurately with GPS and only with GPS. Trigonometric leveling with a total station is not acceptable for vertical control work. Traversing in surveying method. Number 1. Conduct a field reconnaissance at given area determined by lecturer. Number 2. Start working by using compass to get datum value. Number 3. Distance between stations must be more than 30 meters and less than 80 meters. Number 4. The traverse route must consist minimum of 4 stations. Number 5. Set up the tripod and total station instrument at station point. Number 6. Level the instrument through the circle bubble is located at the center. Number 7. Set up first the prism as back station and second prism as forward station. Number 8. Focus and target prism. Number 9. Measure bearing, horizontal distance, vertical angle, and slope distance. Number 10. Transit total station to forward and target the prism foresight. Number 11. Measure bearing, horizontal distance, vertical angles, and slope distance. Number 12. Repeat above steps to complete the traverse. Each group must conduct first-class traverse, complete with field book traverse adjustment and accuracy calculation. The methods are: number 1. Mark point A, B, C, and D in the ground with pegs as shown in diagram 2.0. Number 2. Set up the leveling instrument at point C and read staff readings at point A and B. The reading will mark as A1 and B1. Number 3. Then set up leveling instrument at point D and again take the staff readings at point A and B. The readings will mark as A2 and B2. Number 4. Calculate the height differences from the staff readings using the formula A1 minus B1 equal to A2 minus B2. Number 5. If the height differences are not the same, there is collimation, error, and adjustment to the instrument indeed. Conduct close and series leveling survey. Number 1. Locate the TBM or BM for starting point. This will be the starting station and first backside. Number 2. Set up the leveling instrument at an appropriate position about 30 to 50 meters from the TBM. At the meantime, a staff man will hold a leveling staff vertically with the aid of a staff bubble on the BM. The first reading taken on this staff is known as the BS and booked accordingly as shown in diagram. Next, another staffman shall locate the forward point known as the change point. This is to eliminate collimation error, if any. Number 4. The surveyor will then focus to the forward staff held vertically at the change point. This is the first change point. To read the staff reading, which is known as the foresight, and to be booked. Number 5. At the meantime, while reading the foresight, the staffman at TBM shall move to find the next change point. Number 6. The instrument man shall move to instrument station 2. Make sure the BS distance is equal to FS distance. To make the BS and FS reading an intermediate side may be taken. The last one. The process shall be repeated until the next nearest TBM is reached. If another TBM is reached, the leveling circuit are known as the series leveling. If leveling circuit reach back to the starting TBM, the leveling circuit is known as close leveling.
Topography survey using automation method. Set up and collection of survey data. 1. Press button on and press menu. 2. Press F1 data collect. 3. Press F1 input again if want to create new job and press F4 enter when finished. 4. In data collection screen, press F1 OCC PTH input. 5. Insert all of data PTH ID INSHT by pressing F1 input and press F4 or CNEH. 6. Press FE and EZ. 7. Input the value for N noting EST and Z evaluation by pressing F1 input and press F4 enter after each entry. 8. Press ESC to go to the next screen after input the Z evaluation value. 9. Press F2 backside. Then input for backside pcode and RHD by pressing F1 input and press F4 backside. 11. Press FE horizontal. 12. Press F1 input for input the backside pairing and press F4 enter. 13. Carefully aim instrument at center of the prism. 14. Press FE measure for the distance value. 15. Press FE, FS or SS for collecting survey data. 16. Input data for PTH, PT code, and RTH by pressing F1 input and press FE measure when aiming to home. 17. Then press FE and EZ. 18. The beep sound means the point has been taken. The staff can now be moved to the next point. If you can need to change the point code and prism height for particular survey point, this can be done by pressing the F1 input and F4 enter and press FE measure. Next, download the survey data. 1. Connect to the station to computer via cable and turn power on. 2. Press menu. 3. Press F3 memory MGR. 4. Press F4 twice. 5. Press F1 data transfer. 6. Press F1 send data. 7. Press F1 measure data. 8. Select a file by pressing F2 list and use up and down scroll key to select job for download and press F4 enter. Number 9. Press FE yes to send the measure data. Then when download is complete, turn total station off and disconnect. Open for data download. Connect the total station to your computer or laptop to obtain the survey data by connecting the cable for communicating an external instrument by series signal connector or USB from total station to computer or laptop.
Next is data processing. Create data logging to dinner section and cross section in Excel. Since this practical work was done manually without CDS, the longitudinal section and cross-section data was filled in the Excel from the survey sheet. The survey data in the Excel. For long section, we just need create one table and fill in the content, which are point or chainets, reduce level, and distance. We have 11 chainets to include in the long section table. Next, this is our cross-section table from our group. We create 11 tables because we have 11 chainets at cross-section, and we has right ground level, right side work, center, left side work, and left ground level to include in cross-section tables.
Firstly, we need to set up the units. Decimal for the length is decimal. Precision is 0.000 for the angle. Degree minutes per second, and precision is 0 degree 00 minutes and 00 second, and click right clockwise. And for the insertion scale is meters. Direction is not. Click OK and click OK. Click line. We need to do some horizontal line. Click and types 110.000. Click enter, and then we have the horizontal line. After we do the horizontal line, we need to create a table. It have 11 table we need to create, and I have already created 11 table, and we need to write a text like distance, chainage, radius, level. For the first reduced level is 43.660 and click enter. And now we see like this. After we understand how to do it, we need to finish the long section plan. For example, like this. We need to have a title. Longitudinal section plan change 0 to change 100. And then we need one direction, Sarawak State Kuching District, and the scale 1/500. We need to have a picture for Polytechnic Kuching Sarawak, name of group members, name of lecturer, and date for we submitted the plan. That's all for longitudinal section plan. For the cross section, firstly we need to set up the units, same like long section. Decimal precision is 0.000. For the angle, degree minutes second, precision is 0 degrees 00 minutes 00 second. Click right clockwise, and meters direction is not, and click OK. After that, we click line for create some horizontal line. Right 30. After that, we need to create some table, 5 table. I already created like this. 1, 2, 3, 4, 5, 6. Oh, I'm sorry, is 6 table. And this is I create it for the distance and reduce level. So it means have 7 tables here. And click line for the first reduce level. We add for 43.860 and enter. Yeah, and like that. For the cross section need a left rod and right rod. For example, like this. Offset. Okay. We offset. Okay. We need to offset 63.000. Enter. So we can see for the left and right rods, erase, and then we need to know the center. We write 15, and this is the center of the left rod and right road. After that, add circle and click 0.5 like that. Add a text. Okay, click here and click 2. Enter. Okay. Left road. And right road. Okay. Click enter. After that, we need to move this here and this here for the example. After we understand how to do it, how to do a cross section, we need to do this. We need to do like this for 11 tables. We need to have 11 tables. And for the example is like this. This is cross section length. One, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. After we done, we need to have one direction. Sarawak State Kuching District, scale 1/800. And this is we need to have a Polytechnic Kuching's picture, names of group members, names of lecturer, date submitted, scale, and the title. Cross section CNS 00, CNS 100, group 3. That's all for cross section.
Recommendation and conclusion. In our conclusion, the objective of this laboratory works 2 has been achieved with the guideline by our lecturer, Sir Muhammad Firdaus bin Aminuddin. From this practical work, we managed to conduct longitudinal section and cross-section works using automation software method. We also able to process data and to produce longitudinal section and cross-section and plot detailed plans using civil design and survey CDS and AutoCAD software. Longitudinal is one of the most common applications of runnings, level, and vertical distance measurement for the surveyor. The results are plots in the form of a profile, which is a drawing that shows a vertical cross-section. In a short longitudinal section refers to the process of determining the relevance of points on the ground at mostly uniform interval along a continuous line. Cross-section is other method in longitudinal section. The term cross-section generally refers to a relative short profile view of the ground which is drawn particular to the role of centerline of a highway or other type of the linear projects. Lastly, in the laboratory works, we obtain results data. From the data, we know that the centerline relevant at each reduced level, and with And we take cross-section relevant for the center line and both sides of the center line.